The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS New Zealand, and Software Test Works, we welcome everyone today to this webinar on 5 testing best practices. I am Rex Black, President of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and leader in quality hardware and software testing. RBCS has offices in the United States, New Zealand, Australia, and Sri Lanka with partners around the world. RBCS delivers insight and confidence to our clients, helping them get quality software and hardware products to market on time and with measurable return on investment. RBCS has a team of international consultants that deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. RBCS has helped hundreds of companies reduce development and support costs while assuring the best quality products are delivered to customers. I'm the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1 and 2, Foundations of Software Testing, Critical Testing Processes, and Managing the Testing Process. I hold a degree in Computer Science and Engineering from UCLA, and I am past president of the International Software Testing Qualifications Board and the American Software Testing Qualifications Board. Before we start the presentation, a couple of housekeeping notes. If you have any questions during the course of the webinar, please feel free to submit them throughout the presentation via your webinar interface. Now, there's no need to ask for presentation copies, as the presentation is posted on the web at www.rbcs-us.com on the basic library page. If you are having problems with either the audio or visual components of this webinar, please contact GoToWebinar support. And if for whatever reason you cannot get to the webinar online, or if you are dealing with an unreliable connection, please download the slides from the basic library at www.rbcs-us.com and be sure to use the telephone to connect rather than voice over IP. But if you are able to get to the webinar online, then of course you can use voice over IP to listen to the audio component. All right, on with the show. Today's presentation is on 5 testing best practices, and today I'm happy to be giving a special live webinar in San Francisco from a client's offices. I'm at United Biosource Company. UBC, like all RBCS clients, is a company that cares about testing and quality, and some of their local testing and quality staff are attending today's session, so you might hear them making comments or asking questions in the background. And I've asked them to hold their questions until the Q&A session, but they'll still get a special advantage because their questions come first. Okay, so what is a best practice? So a best practice is, it's like a good habit. It's an approach to doing something that generally gives good results when applied in the appropriate situation and with careful thought. So here's a simple example. It's a best practice to use a hammer rather than a screwdriver to put nails in the wall. Now, that doesn't mean that under some circumstances it would be wrong to use the hammer to put a nail in the wall. If you, for whatever reason, need to use a nail gun, maybe it's more appropriate to use a nail gun than a hammer, right? And sometimes you might need to use a screwdriver to get a nail out of the wall. So there are exceptions, but as a general rule, best practice is if you got a nail that needs to go in the wall, use a hammer, don't use a screwdriver, okay? But you have to think about it. So for testing, I've identified 5 testing best practices that I want to talk about today. These are not by any means the only best practices for testing, but they are certainly important ones that have applied for a number of our clients. So risk-based testing, realistic objectives for testing with metrics, continuous test process improvement based on lessons learned, trained and certified test teams, and intelligent distribution of your test work. So we'll look at each one of these with some examples. So start with analytical risk-based testing. So analytical risk-based testing involves the upfront analysis of quality risks. So we will identify risk items in various categories such as performance and reliability and so forth. And each risk item we will assess the level of risk And the simplest way to do this is based on the likelihood and impact for each risk item. And you can have more factors if you want, but that's really the simplest way to go. Now, having determined the level of risk, the level of risk will then determine for each risk item the extent of test coverage that we want to achieve. Higher the level of risk, the more we test. The lower the level of risk, the less we test. It'll determine the order of test execution. So we'll start with the most risky test cases, the ones that were derived from the highest risk items, and move on to the less risky ones as we go along. And level of risk will also determine the order of test triage if necessary. So if we have to give up some tests, we are going to give up the least risky tests first. So that's analytical risk-based testing. Here's an example from a pilot project that we did for a client. Now this client is Computer Associates, now known as CA. They're, for those of you who don't know, a very large enterprise software company, and this we piloted risk-based testing at one of their sites in the East Coast. And what we did, by the way, this case study is described in an article, which I believe is called Risk-Based Testing in Action, and it's out on the RBCS website on the basic library page, if you want to take a look at it. But this shows the outcome of the quality risk analysis that we did. And let me fire up our happy little spotlight here so I can point at some things for you. You see we've got risk ID numbers, which is helpful to have traceability from the risks down to the test cases that cover the risks. And we have quality risk categories, things like serviceability and functionality and reliability and performance and so forth. And then within each quality risk category, we have identified a number of specific risk items. And this pilot, like many of our pilots, identified, I believe, somewhere in the order of 100 to 120 risk items. And that's a fairly typical number. We see it range anywhere from 100 to 200. As a general rule, if you get a lot more than 200 risk items, you should ask yourself if you're perhaps being too specific. One of the problems, one of the mistakes that you can make in risk analysis is diving down into test design, basically. And you want to keep this at a higher level. You're trying to identify what to test, not how to test it. So for each risk item, you see we've identified a likelihood score and an impact score. So likelihood, how likely is this area to have bugs in it when we get it to test? And impact, how bad would it be if we missed a bug in this area and it went out to the customer? And then the risk priority number, we use a very simple approach here. We multiply the likelihood times the impact to calculate the risk priority number. The risk priority number is the aggregate level of risk. And then we've got some heuristics, some rules of thumb for determining the appropriate extent of testing: extensive, broad, cursory, opportunistic, or none, just report bugs based on the risk priority number. And all of this is described in detail in the risk-based testing in action article that I mentioned. And over here we've got some more traceability to the requirements and design specifications, so the PRS, product requirement specification, or the DDS, the detailed design specification. We have traceability from those documents to the risks, so that if those documents are updated, we can easily identify the risk items that